Hi friends, see in thermodynamics in first part we have discussed about I think up to Boyle's law, isn't it? Up to Charles' law we have discussed, okay? Up to Charles' law. Now let us see about Boyle's law, okay? So this is the last part of thermodynamics. This is second part of thermodynamics. Now in this class we will be discussing about the remaining part of the chapter, that is Boyle's law, okay? So this is given by a scientist called as Robert Boyle. So according to him, the pressure is inversely proportional to volume at constant temperature. The given mass of gas, for a given mass of gas, pressure is inversely proportional to volume at constant temperature. So this is also called as isothermal process. This is also called as isothermal process. దీన్నే మనం isothermal process అని కూడా చెప్పవచ్చు. ఏంటి? At constant temperature, pressure is inversely proportional to volume. Now for example, if you draw a graph for pressure on y-axis, volume on x-axis, okay, for different temperatures. So you will be getting graph in this fashion. Okay, for this is for example T1, T2, T3 degrees centigrade. Now from the graph you can observe the graph is in this fashion. Okay, so here T3 is greater than T2 greater than T1, or temperature T1 less than T2 less than T3. So in this graph you observe the slope is negative slope. You can see what is slope here. What is the slope of the graph? Decreasing. So what is slope? Opposite by, that is dP by dV. dP by dV is the slope, tan theta m. So here what is Boyle's law actually? P inversely proportional to pressure అంటే అర్థం ఏంటి? PV is equal to constant. లేదా P1 V1 is equal to P2 V2 is equal to P3 V3 is equal to constant. This is the statement given by Boyle. So ఇందులో నుంచి మనం స్లోప్ ఎలా కట్టొచ్చు? See here, what is slope? dP by dV. That means d by dV of P. But from here equation 1, what is P? ఇక్కడ నుంచి P ఎంత అవుతుంది? K by V. Put it here. So d by dV with respect to V, what is P? K by V. So if you find the derivative for this one with respect to V, K V power minus 1. So if you find the derivative into V, constant derivative K, derivative of this one with respect to V ఎంత అవుతుంది? N into x power n minus 1. N into x power n minus 1 d by dx, derivative formula. So x power n minus 1 into V power minus 1 to minus 1 minus 1 to minus 2. So this is the d by dV. Okay, but what is K actually? Since K is PV, so put the value here. P in the place of K, PV minus I'll take outside, V power minus 2. V power 1, V power minus 10 ఎంత అవుతుంది? Minus P, this is equal to minus P, V power minus 1. Or you can write this one as minus P by, V power minus will come down, it will become V. So what is the final slope of this graph? That is minus P by V. Slope is tan theta slope. ఎంత అయింది? Minus P by V. Very very important. In the examination they are asking regularly. So this is how you have to calculate the slope of the graph. In this case T3 temperature, and these are also called isotherms. This graph is also called as isotherms. These lines are also called as isotherms. That means at constant temperature the pressure is inversely for a given mass of gas, pressure is inversely proportional to volume, or PV is equal to constant, or P1 V1 is equal to P2 V2. Clear? Okay. Now let us go to the So just now I told you Boyle's law is also called isothermal process. Okay, it is a slow process. See, isothermal process and is very slow. You can give an examples like a piston kept inside a cylinder. అదవుతుంది మీకు isothermal process అనేది it is a very slow process. Example ఏంటి? This is the example you can take. This is the piston rod. For example, 1 mole of gas. This is a cylinder. Okay, so this is piston. So when the piston is slowly moving, okay, from one place to another place, 1 mole of gas is taken in cylinder. Slow process. So isothermal process is a very slow process. Now let us go to the next one, that is adiabatic. Okay, adiabatic. Or we will do one thing. 2 more graphs are there, that also I will give before going to adiabatic for Boyle's law. Boyle's law కి ఇంకో రెండు గ్రాఫ్స్ ఉన్నాయండి, అది కూడా ఇచ్చేస్తాను మీకు. 2 graphs. For example, x-axis, y-axis. For Boyle's law, we will take a graph V versus T. Volume on x-axis, temperature on x-axis. So here one more graph. Again, x-axis, y-axis. This is pressure versus temperature. We know in Boyle's law, PV is equal to constant kada. Okay, and temperature is constant here in Boyle's law. Slow process. So temperature constant lo first volume versus temperature తీసుకుంటే you can see temperature is constant, volume is increasing. Next you will see pressure versus temperature lo you can see pressure is decreasing. Okay, pressure versus temperature, volume versus temperature graph lo volume is increasing, temperature is constant. You can see temperature is constant. Temperature is constant. Okay, pressure is decreasing, volume is increasing. Pressure is decreasing, volume inversely proportional kada. Pressure is inversely proportional to volume. So pressure decrease, volume increase, inversely proportional. Clear? So these are other 2 graphs for Boyle's law. Now let us enter into the next one, that is adiabatic. Okay, let us go to adiabatic process. Very very important one. Or else we will do one thing. Before going into adiabatic, let us do work done. Okay, adiabatic lo velle mundu adiabatic process, which is a fast process. Before going into adiabatic expansion or adiabatic process, let us do an intermediate question, that is 4 marks derivation. Work done in isothermal process. ఇది రెగ్యులర్గా అడుగుతున్నాడు ఎగ్జామ్స్లో. Work done in isothermal process, that is nothing but in Boyle's law. Okay, so for that derivation is very important. Derivation 4 marks derivation IP. So what I'll take is, we already know dW is equal to PdV. Okay, work done is equal to pressure into volume. For 1 mole of gas, PV is equal to RT. We know this also. Gas equation, ideal gas equation. N moles అయితే nRT. R gas constant 8.314 joule per mole Kelvin, absolute temperature, volume and pressure. So ikkada I want the work done. So work done and enti from V1 to V2. So at 0 to W. So work done W is equal to, what is pressure from here? Equation presence of the RT by V. So put it here. Okay na? That is RT by V dV integral V1 to V2. Therefore W, RT constant, I'll take it outside, 1 by V integral. 1 by V and log V. And what are the limits? V1 to V2. Therefore W is equal to RT. upper limit minus lower limit. Upper limit and enta function lo first put upper limit log v2 minus lower limit log v1, and this one take e base, which is called a Neperian base, scientist John Napier. Okay na? So this one is nothing but log a minus log b, that is nothing but log a by log b with base e. So this is the expression for work done for 1 mole of gas. 1 mole of gas adi identidi for 1 mole of gas. For example, for n moles if you want, multiply with n. Therefore work done is equal to multiply with n. N is number of nRT into log v2 by v1 with base e. This is the work done for n moles of gas. Indakadi 1 mole, n mole into multiply with n. R gas constant 8.314. Okay, R value meeku alaga telusu, gas constant 8.314. Okay, joule per mole Kelvin. T absolute temperature Kelvin. V2 volume, final volume. V1 initial volume. Same thing you can also express for pressure, because you know PV is equal to constant kada. So P1 V1 is equal to P2 V2. So from this, what is V2 by V1? P1 by P2. Chuskondi. P1 V1 is equal to P2 V2. So in the place of V2, we can also substitute next thing, and you can change this formula. Same work done, I can write in this fashion, that is nRT into log. In the place of V2, I can put P1, pressure rayachu. P1 by P2 with base E, Neperian base. So this is the derivation for 4 marks in IPE. Very very important in the examination. They'll ask to derive. So ee vidhanga meer derive cheyali isothermal expansion lo, that is work done in isothermal, that is Boyle's law. It's a very slow process. Cheppan kada example, 1 mole of gas is taken in a cylinder. Slowly the piston is moved from A to B or P to Q. Okay, let us go to the next derivation, 4 marks, that is adiabatic process or adiabatic expansion. Let us see what is meant by adiabatic process, that is adiabatic expansion, and we will derive the equation for 4 marks IPE. Adiabatic ante enti? Adiabatic process or expansion. So in this one, best example is refrigeration. Best example is refrigeration. Then fridge antar intlo, freezer. Okay, so refrigeration is a fast process, very fast anamata. Suppose some water is kept inside freezer, when you change the temperature values, within very fast time you can freeze the ice. Okay, so it's a very fast process, adiabatic. And not only that, in this dq is equal to 0, very very important. No heat will be going from outside to inside and inside to outside. Completely it is closed. Okay, completely it is closed, మొత్తం క్లోజ్ చేస్తుంది. అందుకే dq amount of heat is 0 given to the system 0. లోపల నుంచి కానీ బయట నుంచి కానీ సిస్టంలోకి వెళ్ళేది ఏమి ఉండదు. dq is completely 0. And here in adiabatic, one more thing you have to make a name. PV to the power gamma is equal to constant, where gamma is, you know, ratio of specific heat set, constant pressure and constant Cp by Cv we have learned in part 1 thermodynamics, gamma, and V volume, P is pressure. Now let us start the derivation. Okay, let us start the derivation. Now here adiabatic process lo emoutundi, same dW is equal to PdV integral V1 to V2, here 0 to W, left side integration W. Now here from this equation, what is pressure? Pressure is equal to K by V power gamma or K into V power minus gamma. Put it here. Okay, integral P place lo K V power minus gamma dV. Okay, constant bite the integral V1 to V2. Now W constant, I'll take it outside. This is nothing but in the form of x power n dn integral. That is x power n plus 1 by n plus 1. Or if you have minus 1, minus n plus 1 by minus n plus 1. So here what happens here? V power minus gamma plus 1 minus gamma plus 1 integration formula limits V1 to V2. Therefore, work done is equal to K. This one I'll take it outside. 1 minus gamma, and inside function upper limit V2 to the power of minus gamma plus 1 minus lower limit V1 to the power of minus gamma plus 1. Clear? Note on this one. I'll go to the next step. Now see here. I'll write here. So ikkada W is equal to, I'll take K inside 1 by 1 minus gamma. K లోపల తీసుకెళ్ళిపోతాను. K into V2 power minus gamma plus 1 minus K into V1, okay, minus gamma plus 1. Now already I have given PV to the power gamma is equal to constant అని ఇచ్చాను ఇక్కడ చూడండి. PV అంటే అర్థం ఏంటి? P1 V1 power gamma is equal to P2 V2 to the power gamma is equal to constant. So I can apply this one in any fashion. Constant equal to this one or constant equal to equal. So here constant is there. So W is equal to 1 by 1 minus gamma. ఒకసారి కాన్స్టెంట్ ఇది తీసుకోండి in terms of V2. Okay. So if you put it here, P2 V to the power of gamma, V to the power of gamma minus gamma plus 1 minus ఇంకోసారి కాన్స్టెంట్ ఈ వాల్యూ తీసుకోండి. ఎంతది? P1 V1 power gamma V1 power minus gamma plus 1. So here therefore W is equal to 1 by 1 minus gamma. You can see here when bases are same, powers can be added or subtracted. Therefore ఎంత అవుతుంది? Gamma minus gamma plus 1 అంటే ఎంత అవుతుంది? V2 power 1 అంటే P2 V2. అలాగే ఇది కూడా ఎంత అవుతుంది? Gamma minus gamma అంటే P1 V1. Okay? And we already know for 1 mole of gas, what is gas equation ideal gas? PV is equal to RT for 1 mole. 1 mole of gas equation ideal gas. లేదా PV by T is equal to R constant. లేదా P1 V1 by T1 is equal to R. P2 V2 by T2 is equal to R. Clear? Now substitute this value here. W is equal to 1 by 1 minus gamma lo. What is P2 V2? R T2. What is P1 V1? R T1. Clear? Now what I'll do, this equation valid for only 1 mole of gas. Note cheskondi. Please note down. Very important derivation. Very important derivation. Now you can see this is for 1 mole of gas. Work done in adiabatic. Suppose n moles కావాలనుకుని n తో మల్టిప్లై లాస్ట్ లో చేయొచ్చు. ముందు ఇది కంప్లీట్ చేద్దాం. W 1 by 1 minus gamma, you take R outside, bracket lo T2 minus T1. This is for what? 1 mole of gas. For n moles, multiply with n. So n into R by 1 minus gamma into T2 minus T1. This is for n moles of gas. Adiabatic equation derivation. Not only here, this one, you can also change the equation different fashion. Elaga? Multiply and divide with minus 1. Multiply and divide with minus 1. Nothing will be a problem. So when you multiply and divide with minus 1, what happens in this equation? W is equal to W is equal to minus 1 లోపల తీసుకెళ్తే ఏమవుతుంది? Take minus 1 inside. అప్పుడు ఇది ఎంత? T1 minus T2 అవుతుంది. See here. And down what happens? It's gamma minus 1. So this is also valid equation. Either you can put this equation or this equation for n moles of gas. Enti? If you multiply and divide with minus 1, what happens? Minus 1 take inside. Take minus 1 inside. Okay? T1 minus T2. ఇది ఎంత అవుతుంది? మైనస్ లోపలికి వెళ్తే ఇది ప్లస్ అయిపోయి మైనస్, సో గామా minus 1. This is also valid. So this is the derivation, 4 marks, very important in the IP examination. Okay, please practice at home this derivation. Now we will draw a graph for this one. Just now I told you adiabatic is a fast process like freezer, freezing ice. Refrigeration is the best example. Very fast process. Now how you will draw the graph for this one, adiabatic? So let us see the PV graph again. In adiabatic, let us see the PV graph. Okay, x-axis, y-axis, pressure on, y-axis, volume on, x-axis. This is volume of the gas and this is pressure of the gas. So if you observe carefully, the graph goes like this, same. Now in this case, what will be the slope? See here, already PV to the power of gamma is equal to constant we have learned. Adiabatic process law. So what is slope again? Decreasing, negative slope. Slope enti dP by dV, negative, decreasing. And అర్థం ఏంటి? d by dV of P. So what is P from here? Equation P ఎంత అవుతుంది? K by V power gamma. Okay? Or I can write as d by dV of K V to the power of minus gamma. Now I will do derivative of this function with respect to V. అప్పుడు ఏమవుతుంది ఇది? కాన్స్టెంట్ K బయటకు వచ్చేస్తుంది. ఇది మళ్ళీ ఎలా ఉంది? ఇట్ ఈస్ ఇన్ ద ఫార్మ్ x power n dx. ఓకే, d by dx of x power n ఎంత అవుతుంది? n into x power n minus 1. సో కాన్స్టెంట్ బయటకు వచ్చి హియర్ డెరివేటివ్ ఆఫ్ దిస్ వన్ మీన్స్ minus gamma into minus gamma V power minus gamma minus 1. So finally what happened? Minus K gamma, gamma this one not 8, V power minus gamma minus 1. But what is K from here? What is K? PV to the power of gamma. So minus PV to the power of gamma into gamma V power minus gamma minus 1. Clear? So minus P, okay na? Minus P gamma, same base, add up. So add చేసి ఎంత అవుతుంది? V power gamma minus 1 ఎంత అవుతుంది? minus 1. So what happens finally? Minus P gamma by V. So this is the slope. You can see this is the slope dP by dV in adiabatic process. In adiabatic process, what is the slope? Negative slope. How many times it is? You can see gamma times in Boyle's law. In Boyle's law, you can see we got how much? Minus P by V. In Boyle's law. In Boyle's law. In adiabatic fast process, we got gamma times, okay, minus P by V. So here the graph slope is decreasing gamma times. అక్కడ బాయిల్స్ లాలో మైనస్ పీ బై వి, ఇక్కడ మైనస్ గామా పీ బై వి. చూడండి ఇక్కడ రియర్ ఇన్ దిస్ వన్ మైనస్ గామా టైమ్స్ పీ బై, లేదా గామాని లోపల బయట పెట్టేసేయండి, లోపల మైనస్ తీసుకెళ్ళిపోయింది. గామా టైమ్స్ మైనస్ పీ బై వి, పీ బై వి. ఓకే, సో దిస్ ఈస్ ద very important thing. Anyway you can write like this, gamma times or gamma times minus P by V. Minus P by V got in Boyle's law. In adiabatic you got a gamma times minus P by V. Very important derivation in intermediate IP they will be asking, and not only in the NEET exam also they are asking. Please note down. Now let us go different equations in this adiabatic. Sometimes 2 marks also they are asking, or also 4 marks they are asking how to get those equations in different ways in adiabatic. Okay, so let us practice that one. Different equations in adiabatic. In adiabatic process, let us see different equations. Let us see different equations. See, we already know PV to the power of gamma is equal to constant. Okay na? PV to the power of gamma is equal to constant. Clear? So ikkada meer gamaninchinnattugaithe you can change the equation as and when required, because you know PV is equal to RT. What is this equation for? 1 mole of gas, ideal gas equation. Okay, ideal gas equation. So here you can use this one. For example, in the launch in the V V. What is V? RT by P. Substitute here P into, in the place of V, you need RT by P to the power of gamma is equal to constant. Now in the launch R is constant, gone, kindaki vachestadi. So ikkada P, T power gamma, ఈ గామా P కూడా ఉంది, గామా పైకి వెళ్ళిపోతే P పవర్ మైనస్ గామా అవుతుంది, is equal to constant. So P power 1 minus gamma T power gamma is equal to constant. So I can write as P1 1 minus gamma T1 gamma is equal to P2 1 minus gamma T2 gamma is equal to constant. This is one form of writing. Please note down. So we have written the adiabatic equation, process equation in terms of pressure and temperature. In terms of pressure and temperature we have written. Now we will change this equation. Okay na? Pressure, temperature. Maro form lo raadam. Okay, I will change this one now. In different form now I will write. Let us write in another form, that is in terms of volume and other things. See, same thing, PV to the power of gamma is equal to constant. Now I will change this one. We know 1 mole of gas equation anta, PV is equal to RT. ఇందులోంచి వాల్యూమ్ ఇందాక మనం ఏంటి ప్రెజర్ వచ్చింది కదా, ఇప్పుడు వాల్యూమ్లో రావాలి. సో P is equal to, ఒకవేళ RT by V రాస్తే ఏమవుతుంది చూద్దాం. ఓకేనా? ఇందులోంచి if you write P is equal to RT by V and substitute here in the place of P, RT by V into V power gamma is equal to constant. Here R is constant, pakka తీసేయండి, comes down here. So here T power 1, V పైకి వెళ్ళిపోతే V power minus 1, V power gamma is equal to constant, or T power 1, V power gamma minus 1, check it properly, RT by V. Okay, P place lo RT by V. Okay, and here gamma is there, paiki velipothe minus 1, gamma minus 1, very good. So is equal to constant. Now this one you can write it as T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1 is equal to constant. So as and when required, depending upon the requirements, either you have to use pressure temperature equation or volume temperature equation adiabatic. Clear? Right. So these are the equations for adiabatic and isothermal process. Adiabatic is a fast process like refrigeration and a piston. Okay? Inside a cylinder with 1 mole of gas. Slow process, that is Boyle's law, isothermal process. Clear? Now let us go to the almost ending one in thermodynamics, that is second law of thermodynamics. Second law of thermodynamics. We have discussed zeroth law, first law, dq is equal to du plus dw. Zeroth law, A, B, C, 3 bodies with different temperatures joined together, they will attain thermal equilibrium. Now what is this second law of thermodynamics? This second law of thermodynamics ante enti? Okay, it's very very important. It's also called as conservation of energy. Okay, it is also called as conservation of energy. It is also called as conservation of energy. Enti okasari chuddam. Now see, I will do a small example. Second law. Now I am rubbing the hand like this very fastly. You can see. So heat is generated. That means what I am doing now, I am doing this mechanical work. Physically I am this mechanical work. So this mechanical work, due to friction, it is converted into heat energy. So observe carefully. So it is also called a Joule's law. Okay. So W proportional to Q. This is also called as Joule's law, Prescott Joule. Okay. So how much mechanical work you are doing, the same amount of heat is released in calories or kilocalories. Aithe, what second law is telling? That means we can convert mechanical work, entire mechanical work, into heat energy. Okay, we can convert the mechanical work, entire mechanical into heat energy, but it is highly impossible. But it is highly impossible to convert back again this entire heat energy into mechanical work. No matter whatever reversible or irreversible engine is used. మీకు అర్థమవుతున్న పాయింట్. సో సెకండ్ లా స్టేట్మెంట్ ఏం చెప్తారంటే, whoever it may be, either కెల్విన్ ప్లాంక్ స్టేట్మెంట్ ఆర్ క్లాసియస్ స్టేట్మెంట్. కెల్విన్ ప్లాంక్ స్టేట్మెంట్ కూడా అంతే. కెల్విన్ ప్లాంక్ స్టేట్మెంట్, Kelvin and Planck statement కూడా same thing, second law only they are telling. That means it is highly impossible to convert whatever heat is converted energy entire mechanical, because full efficiency ఉండదు. అంటే పూర్తిగా you can use heat engines. You can use heat engine, because heat engine, next topic is that only, last topic, heat engine. Because the main purpose of heat engine is like Carnot's heat engine. You will be getting maximum efficiency. 100 efficiency you won't get, but maximum you will get efficiency. అంటే మొత్తం హీట్ అంతా మెకానికల్లో మార్చడం. Some part will be there, loss of heat will be there. Okay, that is the main statement given by Kelvin Planck or second law of thermodynamics, conservation of energy. That means when mechanical energy is converted into heat energy, it is highly impossible to convert the entire heat energy into mechanical work, no matter whatever engine you are using. And it is found that from practically Carnot's engine, that is the last topic, is getting maximum efficiency. Maximum is not 100%, you won't get 100% mechanical work. Some part will be lost. Okay, that I'll show you in the diagram while explaining Carnot's engine. Okay, so this is the second law statement. It is highly impossible to convert the entire heat energy into mechanical work. This is also called as Kelvin Planck statement. ఇంకోటి కూడా ఉందండి, క్లాసియస్ స్టేట్మెంట్. క్లాసియస్ స్టేట్మెంట్ another scientist, Clausius. So what this person is saying is, for example, cold body is there and here hot body is there. Are you following here? Cold body is there here and hot body is there here. So what they are saying here, ఈ Clausius and the scientist ఏం చెప్తారంటే, it is again highly impossible to take heat from cold body and give it to hot body. Cold body నుంచి heat తీసి hot bodyకి ఇవ్వలేము. That is Clausius statement. It is highly impossible to take heat from cold body and give it to hot body. That is Clausius statement. Okay. Now we'll study about the second law detailedly by studying about heat engines. Okay. Let us see what is meant by heat engine. This is the last topic in this chapter. Let us see what is heat engine. See, mainly heat engines are invented. Okay. Let us see what is heat engine. What is the definition of heat engine? Inda cheppuna kada, second law, conservation of energy. That means heat is converted into mechanical work. Heat is converted into mechanical work. ఇందాక ఏం చెప్పాను, mechanical energy is converted to heat energy. Highly impossible to convert entire heat energy into work. But by using heat engines, some part heat is converted into mechanical work. Now what is the main function of heat engine? Heat engine లో ఏంటంటే ఒక సోర్స్ ఉంటుంది. The main function, and the source will have infinity temperature. Nothing can be taken out. Infinity, bold and the capacity. That is the source T1 degrees. And from here, some heat is taken. And just now I told you, we can Japan entire heat cannot be converted into mechanical work. some part is wasted. So here this is wastage Q2. Okay, this is sink. Let this temperature be T2 degrees Kelvin and make a note, T1 is greater than T2 always. Okay, so ఈ source లో infinity capacity ఉంటుంది, just like reservoir, heat reservoir. It is a heat reservoir, and this is also having infinity capacity of heat. So the main function of heat engine is block diagram. Source infinity capacity నుంచి కొంత heat is taken Q1, and మీకు చెప్పాను కదా, some amount of work is done, mechanical work. Okay, mechanical work. Some amount of heat is taken and wasted. Q2 is wasted and is gone into the sink. Now here what is the efficiency? ఇక్కడ efficiency ఎలా కట్టొచ్చు మనం? Efficiency eta always given by output by input. ఏదైనా efficiency ఎలా వస్తుంది? Output by input. So here output ఏంటి? Output ఎంత? W mechanical work by input ఎంత? Q1. And Q2 is wastage. So ఇక్కడ మీరు గమనించినట్టుగా అయితే, see here, what is W here? Q1 is equal to W plus Q2, or Q1 minus Q2 is equal to W. Okay? సో ఇందాక మీకు చెప్పాను, ఎలాంటి ఇంజిన్ ఉపయోగించిన ప్రపంచంలో, ఓకే, you cannot completely convert the heat into mechanical work. That is the main thing here, second law statement. So here some part is wasted, Q2 heat will be wasted. Okay, so therefore efficiency is given by W. W ఏంటి ఇక్కడ? Q1 minus Q2 by Q1. That is nothing but 1 minus Q2 by Q1. So this is the main equation for efficiency, 1 minus Q2 by Q1. Here Q2 is wastage heat and Q1 is, okay, input here. This is input, please. This is input heat and this is output mechanical work. This is the main function of a heat engine. Okay, this is the main function of the heat engine. Clear? Note down please. Now we'll go to the last part, that is Carnot's heat engine. Let us go to the last part, Carnot's heat engine and also block diagram. Please. So just now I told you the second law is nothing but conservation of energy. Second law is nothing but conservation of energy. Second law is nothing but what? Conservation of energy. Mechanical to heat, heat to mechanical work. Now as I told you, the last one, Carnot's heat engine. See, Carnot's heat engine is the highest efficiency. Highest efficiency. That doesn't mean 100%. Here also wastage. That means out of all engines, Carnot's engine is having highest efficiency. Highest efficiency. Output by input. Now I'll show you the block diagram here. Same. First let us go to the cycle. Then I'll go to this thing. Okay. First then graph చూద్దాం, PV graph. PV graph చూసిన తర్వాత then we'll go to the block diagram. This is pressure on y-axis, volume on x-axis. Carnot cycle లో 4 processes ఉంటాయి, very very important. 4 things. First one is isothermal expansion. Okay, because temperature is constant. Isothermal expansion, first one. Okay, so here what happens? Expanding, gas is expanding. Okay, and ఇక్కడ heat ఏమవుతుంది? Absorb చేసుకుంటుంది. Heat is absorbed, Q is absorbed. Okay, దీన్ని Q1 అనుకుందాం. Second one, temperature constant కదా, తెలుసు కదా, temperature constant. Second one, isothermal అయిపోయింది, adiabatic expansion. Next one is adiabatic expansion, let it be T2. Okay. In adiabatic, already I told you. In adiabatic expansion, I told you dq is equal to 0. Surrounding is closed. No heat is entered inside, or from inside no heat is coming outside. Refrigeration. So dq is equal to 0. Okay. Third one, isothermal compression. Isothermal compression అంటే గ్యాస్ ఈజ్ కంప్రెస్డ్. ఎప్పుడైతే గ్యాస్ కంప్రెస్ చేస్తారో టెంపరేచర్ కాన్స్టెంటే, హీట్ ఈజ్ రిలీజ్డ్. ఓకే, సో హియర్ హీట్ ఈజ్ రిలీజ్డ్, Q ఈజ్ రిలీజ్డ్. సో నెక్స్ట్ వన్, థర్డ్ ప్రాసెస్ isothermal compression. Okay, here heat is released, Q released, because gas is compressed continuously, volume is decreasing and it is showing in the form of heat releasing, Q is released. And last one, adiabatic compression. Last one is adiabatic compression. Again, you know, dq is 0 in adiabatic. Okay, so these are the 4 processes going on in Carnot's cycle. Carnot cycle ఏం జరుగుతుంది, 4 ప్రాసెస్లు ఉంటాయి. Isothermal expansion, temperature constant, heat is absorbed. Isothermal adiabatic expansion, that is dq 0. Okay, and next isothermal compression, heat is released. తర్వాత adiabatic compression. ఈ 4 ప్రాసెస్ very very important in Carnot's cycle. Okay, now we are going to the last one after this graph, that is nothing but very very important, Carnot's heat engine, which is almost more efficient. Okay, and this will be the last topic for this thermodynamics to end up the chapter. Okay, I'll show the block diagram and also equation, and with this the chapter is also over. So let us go to the last block diagram, that is Carnot's heat engine. Carnot's, scientist Carnot. Okay, Carnot's heat engine. So just now I told you it is the highest efficiency, maximum efficiency, that means not 100 but maximum efficiency of the all engines, because we know entire heat cannot be converted into mechanical, but maximum it is converted. So here the block diagram goes like this in same fashion. Source like a reservoir, infinity capacity, T1 degree. Okay, Q1 is given as input heat, mechanical work outside, this is output. Okay, and you know some wastage is there, wastage of heat, Q2, this is sink. This is also having infinity capacity. Okay, and T1 is greater than T2, please. This is always greater than source, greater than sink. Now here Carnot's heat engine efficiency, so I told you maximum output by input. Therefore output and mechanical work output by input heat Q1, or what is W here? Q1 is equal to W plus Q2, or Q1 minus W2 is equal to W. It is coming and it is going too. Okay, so here what is W? Q1 minus Q2 by Q1, లేదా Q1 by Q1, that is 1 minus Q2 by Q1. This is maximum efficiency given by Carnot's heat engine, and sometimes this is also written as 1 minus T2 by T1, because Q2 by Q1 is equal to T2 by T1. Very very important formula while doing numericals in MCET or NEET examination. This is the entire equation for Carnot's heat engine. It is the highest efficiency, Carnot's maximum efficiency. Okay, clear? Now we are going to the last one. The reciprocal of Carnot's is nothing but refrigeration. అదే లాస్ట్ అండి, దాంతో మనకు అయిపోతుంది ఇంకా. దట్ ఈస్ లాస్ట్ వన్. హ్యావ్ యూ నోట్ డౌన్? ఓకే, Last one. This is the reciprocal of Carnot's heat engine. Reciprocal. So that is the last one. Refrigeration. Refrigeration. So refrigeration is the reciprocal, reverse of Carnot cycle. So the Carnot's engine. Okay? Reverse of Carnot's engine, Carnot's heat engine is refrigeration. అదేంటి చూడండి ఇక్కడ. See here, it is a freezer. Okay? From here, the heat is taken out. Okay? That is output. Qt is output, and this is surrounding room, and here also T1 degree Kelvin is greater than T2 degrees Kelvin surrounding temperature. Then the freezer is T2 degrees Kelvin. And here one thing you have to make a note. Fridge panchayalante freezer continuously electricity should be supplied. Electrical work. And here this electrical work W here is acting as input. So when you switch off the electricity, no freezer won't work. So continuously electricity should be supplied. So electrical work is input here, and with this it is pulling out some heat from the freezer, that is Q2. So this is input and this is output, and Q1 heat is given to the surroundings. Now here, just now I told you it's a reverse of Carnot's heat engine. Enti? Refrigeration. So in this case we won't call efficiency, we will call as coefficient of performance, K. K is called as coefficient of performance. So here efficiency is nothing but K here. This is again once again output by input. Therefore K, ఇక్కడ output ఎంత freezer నుంచి లాగుతుంది ఎంత Q2 heat లాగుతుంది. So Q2 by what is input here? Electrical work continuously, that is W. So therefore coefficient of performance is Q2 by what is W again? You can see W and Q2 are meeting here and Q1 coming out. So Q1 is equal to W plus Q2 or Q1 minus Q2 is equal to W. So put it in the place of W ఏంటి ఇక్కడ Q1 minus Q2. So this one also you can write as Q2 T2 by T1 minus T2. So you can take this equation or you can also take this equation. K is equal to T2 by T1 minus T2, where T1 and T2, I'll write it here if you are not able to see. If you are unable to see, I'll write here. K is equal to T2 by T1 minus T2. Coefficient of performance is nothing but temperature at the freezer by temperature of the source, source in the sense here room, surroundings, minus freezer temperature. And all are kept in Kelvin, absolute temperature. So just now I am telling you, refrigeration is the reverse, reciprocal of Carnot's heat engine. So these are very, very important regarding examination point of view. They may be asking in the entrance exam, either NEET or in IPE, they may be asking, or in even MCET examination. So please prepare well this thermodynamics. So I have explained very clearly in part 1 and part 2. So this is the end of the thermodynamics chapter. Okay? See you.